Day 618 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 85, maximal rectangle. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given a rows times cols binary matrix filled with zeros and ones, find the largest rectangle containing only ones and return its area. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in our input, in example 1, our input is a matrix of a 2D array of strings. First array 1 0 1 0 0, next array 1 0 1 1 1, next array 1 1 1 1 1, and the last array is 1 0 0 1 0. The output is 6. Explanation says the maximal rectangle is shown in the picture above. So this is the grid that they give us, right? And it's important to remember that each one of these arrays inside the 2D array represents a row. So this would be row 2. This right here would be the top row. Boom. Then this right here would be the second row right here. Boom. This right here would be this row. Boom. And then this last row would be this last array right here. Boom. And what we want to do is find the biggest rectangle that we can find in this grid. So in this case, they have the rectangle highlighted with ones right here. So that's the biggest rectangle. It has an area of 6, as you can see, because the area is length times width. So it's 2 by 3. 2 times 3 is 6. Thus, the output is 6. Boom. So just in case that didn't make sense, let's look at example 2 where they try to throw some trick questions our way. So in example 2, our input matrix equals in a 2D array of strings, and that with just one array, and that array only contains one string, and that string is 0. So the output is 0 because there are no ones in this matrix at all, so we cannot create a rectangle filled with all ones. Similarly, in example 3, our input matrix equals a 2D array of strings with 1 being the only string in there. So 1, since that's the only cell, then that means the cell will be 1 by 1. 1 times 1 is 1, so our output is 1. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. Now, first thing we're going to do is we're going to create a variable to represent the height of consecutive ones in column J up to the current row. So we'll just create a variable. We'll call it cur height. We can just call it cur height. Boom. And then we'll set that equal to an array. Open up the parentheses. It is going to be repeating :0, comma count, colon, matrix, square bracket, 0, come outside of that square bracket, dot count, boom. Then we need a variable to store the maximum rectangle area that we found, so we can come underneath this, declare a variable called result, and set that equal to 0. Then we need to iterate through each row of the matrix. So we'll say for I in 0 dot dot less than matrix.count. We'll open up the brackets, and then we're going to update the histogram for the current row. So we're going to say, and so we are going to say, and this is the histogram right here. So we could just call this cur hist, boom. Then, so we'll say for j in 0 dot dot less than matrix square bracket I, come outside of that dot count. Sorry, y'all, should be a dot count. We'll open up the brackets and we'll say if matrix square bracket I square bracket j equals, open up the quotation marks and pass in 1. Open up the brackets. We're going to increase if the current cell is 1. So we're going to increase the current histogram by saying cur hist square bracket j, come outside of that, plus equals 1. Boom. Else we can reset the height if the current cell is 0. So we could come right here and we can say else, open up the brackets, cur hist square bracket j, just set that equal to 0. Boom. Now we're going to try all possible rectangle heights up to the current row. So we'll come underneath this for loop, still inside the other for loop, and we're going to say for height and 1 dot 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 I plus 1. We're going to open up the brackets and we're going to declare a variable called width, set that equal to 0. Then we're going to scan the histogram to find consecutive columns where the height is at least height. So we're going to say for j in 0 dot dot less than cur hist dot count. We're going to open up the brackets and we're going to say if cur hist, cur hist square bracket j is less than or equal to height, then we're going to open up the bracket and extend the rectangle width by saying width plus equals 1. Else, the height is insufficient and we need to finalize the area calculation by coming right here. We're going to come right here. We're going to say else, open up the bracket. We're going to say result equals max, open up the parentheses, result, comma, height times width. Boom. And whichever one is larger, it's going to return whichever one is larger. The result or the height, the result or the height times width. Boom. Then we're going to come underneath this, set width equal to 0. Then we're not done yet, y'all, because we still need to check the last possible rectangle in the row by coming right here. We're going to say result equals max, open up the parentheses, result, comma, height times width, and then we're going to return the maximum rectangle area found by coming right here, and we could just say return result, y'all. Boom. That should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 15 milliseconds beats 25% of users. Not bad, not too bad. We can definitely get those numbers up, but we'll focus on getting those numbers up as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us, and I feel like this is a good solution for that. So, with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.